Good morning, students. Myself, Vijay Shankar from EC Department, Civil Engineering College. Today, we are going to discuss about the new chapter that is fourth unit, magnetostatics. The previous class discussed about the electrostatics, that is the third unit, and I'll go for the next unit is the fourth unit, the magnetostatics. Before going to the magnetostatics, can brief description about the electrostatics and their formulas. The electrostatics, before the electrostatics, the Coulombs Law. The Coulombs Law. Coulombs Law saying that is a F bar is equal to, or F bar is equal to the product of two charges, Q1 and the Q2, is directly proportional and inversely proportional to the square of the distance between them. Square of the distance between them, R square. And that proportionality constant is a 1 by 4 pi epsilon naught into Q1, Q2 by R square. Because it is a F bar, it is a AR bar, the unit vector. Therefore, finally, the F bar is equal to Q1, Q2 by 4 pi epsilon naught R square into AR bar. Coulombs law, the force is exerted. Then the electric field intensity, E bar is equal to the force per unit charge, F bar is equal F bar by Q. What is a F bar here? The F by Q means is a Q by 4 pi epsilon naught R square into AR bar. R square into AR bar. Therefore, it's a point charge. E bar is equal to Q by 4 pi epsilon naught. Let it be the R is R distance and A is the AR distance, A bar. The electric field intensity at the point charge. Electric field intensity at the point charge. Now, the charge distributions. First one is line charge. Line charge is the change of the charge dq by the dl is equal to rho l. Okay, so dq is equal to rho l into dl. So what is electric field intensity in the line charge? Electric field intensity, differential electric field intensity, dE bar is equal to, so dq by 4 pi epsilon naught R square into AR bar, that is equal to, by substituting the dq is equal to rho l into dl as a line charge. The electric field intensity E bar, dE bar is equal to rho l dl whole divided by the 4 pi epsilon naught R square into AR. Okay, otherwise E bar is equal to, I'm not taking that directly, it is a differential. Let it is E bar is equal to, it's a line integral. Line integral rho L by rho L dl by 4 pi epsilon naught r square into AR. For the surface charge, that is a dq, the change of charge dq by ds is equal to rho s, where rho s is coulombs per meter square. Here the coulomb per meter only, because the length is in the meters. Surface is m into m meter square, that is the area A. Volume means a meter into meter into meter, the meter cube, coulomb per meter cube. So directly can substitute this dq is equal to rho s into ds. The change of charge in the surface, a differential surface. Directly I am writing here is E bar is equal to, in this equation only, the dE bar is equal to dq. The dq in terms of the rho s and ds is a surface integral rho s ds by 4 pi epsilon naught r square into AR bar. R square into AR. Surface charge and the line charge. Similarly, the volume charge, the another distribution, charge distribution, the volume charge. Volume charge is also the same, the dq by the dv is equal to rho v. So what is a rho v? Coulomb per, the charge is coulombs and the volume is a meter into meter into meter. 3 sides we can take, it's a meter cube. Nothing but simply saying the A into L, the area and the L. S is equal to A and L, you can multiply that, becomes a volume. Implies, here also you get the dq is equal to rho v into dv. Directly I am writing here the E bar is equal to electric field intensity integral. This integral is a volume integral. Volume integral rho v dv by the 4 pi epsilon naught r square into AR bar. Okay, my dear friends. So from the Coulombs law, the force is directly proportional to the product of two charge carriers Q1 and Q2, and inversely proportional to square of the distance between them. And the definition of the electric field intensity or the electric field strength or electric strength is force per unit charge. Force per unit charge. E bar is equal to Q by 4 pi epsilon naught R square into AR bar. That we can take it as a point charge. The electric field intensity at the point charge. Similarly, the charge is distributed in the line charge. Different uniform distribution of the charge is there on the line, on the surface, and the volume. The electric field intensity E bar is equal to rho L dl by the 4 pi epsilon naught R square and rho S ds by 4 pi epsilon naught R square and rho V dv by 4 pi epsilon naught R square. Okay, my dear students. This is electric field intensity. And electric flux density. Electric flux density. See, electric flux density means it is denoted as a D or it is a D bar. The relation between of electric flux density and electric field intensity is D bar is equal to D bar is equal to epsilon naught into E bar. Epsilon naught into E bar. For point charge, the electric field intensity E bar is equal to Q by 4 pi epsilon naught R square into AR bar. Now using this relation, the electric flux density D bar is equal to Q by 4 pi epsilon. There is no any epsilon naught because epsilon naught get cancelled when you can substitute the E bar in this equation. 4 pi R square into AR. Is electric field, not the electric field, electric flux density, the point charge. And line charge, the electric field intensity E bar is equal to the line integral rho L dl by 4 pi epsilon naught R square into AR bar. Now, the electric flux density D bar is equal to, without epsilon naught, the line integral Q, not the Q, rho L dl by 4 pi R square into AR bar. The D bar is equal. Similarly, for the surface charge, E bar is equal to the integral surface rho S ds by 4 pi epsilon naught R square into AR. Okay. Now, the electric flux density D bar is equal to the surface charge, not the surface charge, the surface integral rho S ds by, without epsilon here, 4 pi R square into AR bar. The D bar is equal. Similarly, the last charge distribution, the volume charge here. The volume charge E bar is equal to the volume integral rho v dv by 4 pi epsilon naught R square into AR. Coming to the electric flux density, the D bar is equal to the volume integral rho v dv by 4 pi R square into AR. Okay, my dear students. By using this relation, D bar is equal to epsilon naught into E bar. Okay, my dear students. Is due to the line charge, electric field intensity due to the line charge, surface charge, and volume charge, like that. And another application is also there. That is electric field intensity due to the infinite line charge. Electric field intensity. Electric field intensity due to infinite line charge. Infinite line charge. Okay. Normal line charge we see electric field intensity due to the infinite line charge, the E bar is equal to, we got the E bar is equal to, I will write here in the, because electric flux density also you have to write down, E bar is equal to, because it is a line, rho L by the 2 pi epsilon naught R into AR is E bar is equal to electric field intensity due to the infinite line charge. The same way, the electric flux density due to the relation of D bar is equal to epsilon naught into E bar. You'll get the electric field intensity, electric flux density also. Electric flux density D bar is equal to electric flux density due to the infinite line charge D bar is equal to rho L by, without epsilon, rho L by the 2 pi R into AR bar. Okay, into AR. Electric flux and the electric field, both we got it, my dear students. Now, another one is there, electric field intensity. Electric field intensity due to circular, charged circular ring. Due to charged circular ring. These are all the formulas you have to remember, and you can do some examples after the completion of the theory part totally. Okay. We completed the first, second, and the third units of the theory part. And in the second unit, there is a switch chart is there, that is a problematic, and we do after the completion of all the units of theory part in the last. And what is the electric field intensity due to the circular ring? The circular ring means a small differential length we are assuming on the circle. That is also the DL only. That is also the DL. In this, the R component is eliminated. In the previously infinite line, the Z component is eliminated. R component is eliminated in this, and previously the Z component is eliminated in this electric field intensity to the infinite line. Now we are doing that, the electric field intensity due to the circular, charged circular ring. E bar is equal to, after the cancelling of AR bar component, only the AZ component only we get. E bar is equal to rho L R into Z by whole divided by the 2 epsilon into R square plus Z square whole power 3 by 2 whole power 3 by 2 into AZ. So actually this is the AY bar here, and here also the AY bar. AY bar and AR bar is the one direction only. The electric field intensity due to the charged circular ring. And here also by using this relation, the D bar is equal to electric flux density due to the charged circular ring. D bar is equal to, without the epsilon, rho L R Z. Rho L R Z whole divided by the 2 into R square plus Z square whole power 3 by 2 into AZ bar. Got it, my students? Into AZ bar. Similarly, the third one is there, that is electric field intensity due to the infinite sheet of charge. Means you can assume a sheet on XY plane at Z is equal to 0. At Z is equal to 0, the XY plane, and you can assume a small differential surface area on the sheet, and you have to find out the electric field intensity. The point is on the Z-axis. Here also, the AR bar component is eliminated. And finally, we'll get the electric field intensity due to the electric field intensity due to infinite sheet of charge. Infinite sheet of charge. Got it, my students? See, these are infinite line and circular wrinkles also will have the charges on the length only. Okay, the rho L. Now it is a sheet, means the E bar is equal to, in terms of the rho S surface, rho S by the 2 epsilon naught AZ bar, or it is in the AN bar only. Actually, it is a AZ bar when it is X on the XY plane and Z is equal to 0. If it is in the below the Z is equal to 0, the value, the direction is a minus AZ bar. Okay, using this relation, the D bar is equal to epsilon naught into E bar. The electric flux density due to the infinite sheet of charge is D bar is equal to rho S by 2 only. Rho S by 2 AN bar. Because it's a vector, it always you have to show the direction also, including the magnitude. Got it, my students? So the electric field intensity due to the infinite line, and electric field intensity due to the charged circular ring, and electric field intensity due to the infinite sheet of charge. These are all we derived in the previous classes of third unit electrostatics. Okay. And coming to the next one is Gauss law. Gauss law of electric field. Gauss law of electric field. See, we know the Gauss law of electric field, the formula is Q is equal to integral D bar dot ds bar. Is a formula for the Gauss law for electric field. By using the Gauss law, we can derive again electric field intensity due to the infinite line, electric field intensity due to the circular ring, and electric field intensity due to the infinite sheet of charge, and the electric field due to the, it's not the electric flux, electric field intensity due to the line charge, due to the surface charge, and due to the volume charge also. By using the Gauss law of electric field, Q is equal to integral D bar dot ds bar. It is also equal to the magnetic flux psi. Psi is equal to Q. Q is equal to integral D bar dot ds bar. From this relation, we can find out by using the Gauss law, we can find out the one of the Maxwell's equation. The first Maxwell's equation, simply saying that it is Q is equal to integral D bar dot ds bar. Q is equal to D bar dot ds bar. So the surface integral is converted to the volume integral. surface integral is converted to the volume integral by taking the dot del dot the d bar del dot d bar surface integral. I am converting to the volume integral by using the divergence theorem or Stokes theorem. D bar dot ds bar is equal to del dot d bar into dv is a volume integral. Now, what is the q here? Is also equal to the q or psi. That q, we can write it as you see, we know that q is equal to, or in terms of the volume, the change of charge with respect to the volume is the charge density, volume charge density, Coulomb per meter cube. Coulomb per meter cube. So from this, the TQ is equal to rho v into dv, and apply the integral on both sides. It becomes of q is equal to the volume integral, the rho v into dv. So substitute this q here. Integral, volume integral, del dot d bar into dv is equal to q is the volume integral, rho v into dv. So both sides we have volume integral only. So del dot d bar is equal to rho v. Is a first Maxwell's equation. First Maxwell's equation. Okay. Del dot d bar is equal to rho v. Maxwell's equation. Okay, by using the gas law, the q is equal to integral d bar dot ds bar. Okay, you can derive the electric field intensity due to the surface, line, volume, and infinite sheet and infinite line, and circular ring by using the gas law also. And d bar is equal. Understood? See here, we have to know the electric field intensity, nothing but V by M, volts per meter, and the volts per meter. E bar is equal to all the units here. Everything is a V by M, and this is also the V by M. And this also electric field intensity, and electric flux density d bar is equal to electric flux density d bar is equal to Coulomb per meter square. Coulomb per meter square is all these things. It is a Coulomb per meter square only. The Coulomb per meter square. Coulomb per meter square. And here also the same thing. The units, the gas law by using. You can derive all the equations by using the gas law. For infinite sheet also, by using the gas law, you can derive. And you can, another one is there. Gradient of V or the potential and the work done W is equal to the work done W, voltage or the potential, nothing but is a potential. V is equal to in terms of R is proportional to 1 by R. The work done is equal to, what is the work done is equal to work done and the potential. First of all, you can see the work done W is equal to minus Q integral E bar dot dl bar. E bar dot dl bar. The work done is equal. And the potential potential V is equal to work done per unit charge W by the Q. That is equal to minus integral E bar dot dl bar. Integral E bar dot dl bar. So we can, by using the electric field intensity all over the formulas we have, we can substitute and apply the differential length along the X or along the R directions. We will get the potential due to the infinite line, potential due to the point charge, potential due to the line charge, potential due to the surface, and potential due to the volume, infinite line, and the infinite sheet also. Okay. And potential, the electric field intensity at the point charge is a Q by 4 pi epsilon naught R square. And the potential at the 2 points, we will get the V is equal to the point charge only, the Q by potential at the point charge, Q by 4 pi epsilon naught, where it is a 1 by REA, 1 by REA minus 1 by RB or 1 by REA plus 1 by R. So both are can add the potential V is equal to VA plus VA means Q by 4 pi epsilon naught RA. VB means Q by 4 pi epsilon naught RB. So actually it is a minus. Here the minus is there. The charge is the negative charge. Or it is a plus. Okay. Otherwise, simply saying the RA plus RB is equal to the same. The potential, the point charge of the potential is Q is V is equal to Q by 4 pi epsilon naught R. Epsilon naught R. So taking at the point A at the point B, the potential at the point charge, the Q by 4 pi epsilon naught R means V is proportional to the 1 by R. V is proportional to 1 by R. When it is in the line charge, same thing, it is a line charge due to the line charge, due to the surface charge, and due to the volume charge. So first of all, you can take the line charge. Potential due to line charge. We know the line charge means dV is equal to, you have to write down, dV is equal to dQ, or dQ, the line charge dQ is equal to rho L into dl. Rho L into dl. Actually, the point charge is differential voltage, or the differential potential is a dV is equal to dQ by 4 pi epsilon naught R. 4 pi epsilon naught R. And now, if the line charge, substitute dQ as a rho L into dl. Rho L into dl. Therefore, the potential V is equal to the line integral rho L dl by 4 pi epsilon naught R. 4 pi epsilon naught R is a volts. Is a line charge due to the line charge, potential due to the line charge, potential due to the surface charge, potential due to the surface charge. Same thing, dQ is equal to rho S ds is dV is equal to the same. You can use the point charge only. V is equal to, now it becomes of surface integral rho S ds by 4 pi epsilon naught R is also the volts. Got it, matters. Now, the volume charge, the potential due to the volume charge dq is equal to rho v dv. So now the potential V is equal to the volume integral rho v dv by 4 pi epsilon naught R into, that is a volts this also. So potential due to the line charge, potential due to the surface charge, and potential due to the volume charge V is equal to V got. And similarly, the potential due to the infinite line charge, potential due to the infinite line charge. So what is electric field intensity to the infinite line charge? Substitute that in the V is equal to, we know here, see, electric field intensity to the infinite line charge rho L by the 2 pi epsilon naught R into AR bar. Use this formula and substitute this in the potential V is equal to integral minus integral E bar dot DL bar. E bar dot DL bar. That is equal to integral minus, what is the E bar due to the infinite line charge? This is for infinite line charge. Potential due to the infinite line charge. What is the E bar is equal to? We know the rho L by the 2 pi epsilon naught R into AR. Rho L by 2 pi epsilon naught R into AR bar. Dot, what is a DL bar? DL bar is a DR into AR bar and something is there. We have only taking that is a DR into AR bar. DR into AR bar. So AR bar dot AR bar is equal to 1 and rho L by the 2 pi epsilon naught is the constant and this integral is with respect to the R. So 1 by R, nothing but R power minus 1. And 1 by R into R is a ln of will get. Now the potential due to the infinite line charge V is equal to, after applying the integral here, we get the rho L by 2 pi epsilon naught is constant. 2 pi epsilon naught is constant, and this is initial value is a B and final value is a A. ln of RB by, because it is a minus is already there. Actually, it is RA by RB. By substituting that is a minus also RB by RE. Is a potential due to the infinite line charge. RB by RA. Sorry. RB by RE. Potential due to the infinite line charge. Got it, my students? And now the gradient of V. We know the other one is there, gradient. Our grade V is equal to minus E bar. That is equal to del V. Therefore, E bar is equal to minus del V. Minus del V. It's a very important gradient of V or grade V. The relation between the E bar and the potential V is equal to. And in this, for the Cartesian coordinate system and spherical coordinate system and the cylindrical coordinate system, del V is equal to del V for Cartesian coordinate system. Del V is equal to dou V by dou X into AX bar dou v by dou x into ax bar plus dou v by dou r, not the dou r, dou y ay bar plus dou v by dou z az bar. This is for Cartesian coordinate system or rectangular coordinate system. Let us say it's a confusion when I am using that is a cylindrical, it's a C also. Rectangular coordinate system and cylindrical coordinate system. Del V is equal. Here the coordinates are there, R, phi, and the Z. So dou V by dou R into AR bar. And phi is multiplied with the 1 by R is there in the differential elements. 1 by R into dou V by dou phi into A phi bar plus dou V by dou Z into AZ bar, because the Z is the same in the cylindrical coordinates also. And the last one, the spherical coordinate system, that del V, the gradient V is equal to dou V by dou R into AR bar is the same thing in the cylindrical coordinate system. And second quadrant is a theta, so 1 by R is multiplied for the d theta, dou V by dou theta and A theta bar. And third quadrant is R sin theta is multiplied with the d phi, so 1 by R sin theta, 1 by R sin theta, and it is a dou V by dou phi A phi bar. Here it is the A phi bar. A phi bar. What it matters to us? This is one of the gradient, the potential and work done. And in the last class also we discussed about the electric dipole. Assume a point A in the charge Q and point B the charge minus Q, and the distance between the A and B is D, and the point P is there. From A to P is R1 and B to P is R2, and origin to the P is the R. Okay, from that the monopole, the electric field intensity to the monopole is proportional to 1 by R, and now the dipole is proportional to monopole, is means a single pole. The potential is proportional to 1 by R only, because the Q by 4 pi epsilon naught R is the potential. Electric dipole considered is what is the electric field intensity and the potential V is equal to. The electric field intensity E bar is equal to the electric dipole is QD by 4 pi epsilon naught R square, 4 pi epsilon naught R square into 2 cos theta AR bar plus sin theta into A phi bar. Sin theta into A theta bar, or the phi A theta bar. The electric field intensity for the electric dipole E bar is equal to. Now, what is the potential? Potential V is equal to the dipole, the QD cos theta by the 4 pi epsilon naught R square for the electric dipole. See, here also the electric field intensity E bar is proportional to 1 by R square, and not the 1 by R square, my dear students, is 1 by R cube. Sorry, a 1 by R cube. For the point charge, the electric field intensity means monopole, the electric field intensity is proportional to 1 by R square. Is for monopole. And the potential also for the monopole, the V is proportional to 1 by R only. This is for these two are for monopole. For electric dipole, the potential V is proportional to, this is a square, my dear students, R square. So 1 by R square. V is proportional to 1 by R square. Electric field intensity Q by 4 pi epsilon naught R square into AR bar. That is a proportionality of 1 by R square. And whenever it is a dipole, E bar is equal to QD by 4 pi epsilon naught R cube. Totally you can consider as a constant. Okay. By using the dipole moment, the potential and electric field intensity. What is electric field intensity? E bar is equal to, when the equation for the dipole moment, E bar is equal to, this QD is a P bar dot AR bar actually for the potential, and E bar is equal to QD is a P. So the P by the QD is equal to P by 4 pi epsilon naught 4 pi epsilon naught R cube into 2 cos theta AR bar plus sin theta into A theta bar. Okay, this is electric dipole. The dipole moment, substituting of QD is equal to the P. P is nothing but dipole moment. Similarly, for the V, the potential dipole moment for the potential, the QD cos theta is a P bar dot AR. P bar dot AR bar whole divided by the 4 pi epsilon naught R square. This volts per meter and these are volts. The electric field intensity for the electric dipole is proportional to 1 by R cube, 1 by R square, and 1 by R square here, and 1 by R on quarter pole and the octal pole. It becomes of 1 by R power 4, and it becomes R power 4, 3, and so on. It is increases. Got it, my students? And the capacitance we know, the C is equal to epsilon naught into or epsilon into A by D. Is a capacitance, a parallel plate capacitance C is equal to epsilon A by D. Capacitance. By using this, the energy density equation, WE is equal to, we know the 1 by 2, the integral E bar dot D bar. Energy density in terms of E bar and D bar into dV. Okay, into dV is there. The energy density in terms of E bar and D bar, or energy density in terms of only the E bar is there, E square. So WE is equal to 1 by 2 into the volume integral here, E bar. E bar, you can represent it as D bar as epsilon naught into A bar. So epsilon naught into E square. Epsilon naught into E square into D. In terms of only E, and the same energy stored, energy density WE is equal to 1 by 2, the integral P D square by epsilon naught, because substituting the E bar as D bar by epsilon naught into dV. in terms of E bar and D bar, and in terms of only the E, and in terms of the D. In this, the capacitance C is equal to A by D, the energy density, the WE is equal to 1 by 2 CV square. You get the 1 by 2 CV square. The last topic we discussed in the last class. W is equal to CV square, 1 by 2 C into V square. The potential, the relation between the energy density, the capacitance, and the potential, 1 by 2 CV square. This is a brief description what we discussed in the UINT-III. All the formulas you have to remember, my dear students. The next class, we start the fourth unit, magnetostatics. What we discussed here, the electric field intensity. There in the magnetostatics, we discussed about the magnetostatics. Electric field, there is a magnetic field. Electric flux, there is a magnetic flux. And remaining is same due to the line charge, due to the point charge, due to the surface charge, due to the volume charge and infinite line charge, infinite sheet of charge, like that. The same thing, electric field intensity here, there is a magnetic field intensity due to the point charge, magnetic field intensity due to the surface charge, volume charge, and infinite line and the infinite sheet of charge also. Okay, but the electrostatics, we start with the Coulombs law, and magnetostatics, we start with the Biot-Savart's law. Okay, using that law, we can derive the magnetic field, magnetic flux, and the charge distributions also. The next class, we can start the fourth unit. Okay.